Hello, ladies, gentlemen, and in between, and welcome back to another episode of Maths with Hamblin with your beautiful host, Hamblin. And guys, so sorry for being dead for like 2 weeks and just not uploading anything without any kind of explanation. Just, Hamblin's been a busy man the last 2 weeks. What can I say? I got a lot of things going on. Anyway, enough about my personal life. In this episode, we're going to expand upon what we did last time with graphing cubics, and we're going to learn how to solve cubic inequalities. It's going to be a wild riot. Now, let's get into it, my boys. Okay, so first of all, my boys, let's see what I mean by cubic inequalities. So the kind of equations we're going to try and solve today are much like quadratic inequalities, where you've got some cubic function and it's greater than 0. You're trying to solve the value of x such that this is true, and if you look at it at first glance, much like quadratic inequalities, it looks absolutely horrible. How would you even approach this? But pretty much almost exactly the same as quadratic inequalities, there's a very clever trick we can use up our sleeves. If we can draw the graph of this function, we can solve this, and I'll show you what I mean. So let's pretend we drew the graph of this, uppy downy like this. Now, this is amazing for us because, as you can see, we can visually see which values are greater than 0 and less than 0. For example, you can literally see that x value is greater than this root over here. Always you get bigger values than 0, you get positive numbers. So those are all going to be solutions to this inequality. And same goes for the little band of values here that are outputting positive y values there. So if we can accurately graph our cubic, then we can solve the cubic inequality. So without further ado, let's get into an example. Okay, my boys, so this first problem up here, we've got this lovely cubic function here, f of x equals 3x plus 1 multiplied by 3 minus 2x multiplied by x plus 4, and we've got to solve the equation f of x is less than 0. So putting that into English language, we've got to solve the values of x such that when you chuck them into here, you get negative numbers. Okay, and as discussed before, if we can graph that function, and then we can solve our inequality real easy. So let's graph this function. Now, remember what we need to do to graph this function accurately. And for our purposes, we're going to need to graph it accurately. We're going to need all the intersection points of the xy axes, and we're going to need the general shape of the cubic, whether it's an ooh or a ooh, right? And you can tell that from the coefficient of x cubed. And that's the easiest thing to do first, because take a look a second. If we're going to expand this out so we can actually get the coefficient of x cubed and see if it's positive or negative, we can actually do a shorthand of that, because the only way to get an x cubed is to multiply the 3x by the 2x by the x, right? And when you do that, you're going to multiply a positive by a negative by a positive. So we can therefore conclude that when we expand it out, we're going to get a negative number multiplying our x cubed. Therefore, we can deduce the general shape of our cubic. And if I draw the xy axis here a sec, we can deduce the general shape of the cubic will start from the top left and go swoop, 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 and then back down. Okay, so that's brilliant. We've already got the general shape. Now all we need to do is find the roots of this function, i.e. we need to solve when it equals 0. So we can plot them on here, graph our cubic lovely and dandly, and then solve our inequality. So, and luckily for us, I have given the question in factorized form, so it's really easy to solve for the roots. So if we set this bad boy equal to 0, that's kind of scuffed, but you can see, well, we use the same logic we always use. We've got 3 things multiplying together and they equal 0. Therefore, we can deduce that one or more of these must equal 0. So let's go bracket by bracket and see what we can find out. So if this one equals 0, then that requires x to be equal to negative 1/3. Okay, let's plot that there. So at the value x equals negative 1/3, we get a y value of 0. Absolutely cool. Next one, it's not too hard to see that the value of x there is 3/2. So therefore, our next one is x equals a positive 3/2. Absolutely fantastic. And the last one, super simple, x equals -4. Don't even have to think about that, right? That's going to be way over here, but I'll just put it there. So absolutely fan-dabby-dozy. We've got our, actually those are a bit small, so I'll just make those a bit bigger for you guys. I hope you don't mind that. I think you can see those slightly better. Yeah, should be fine. Anyway, so now we know the general shape of our cubic, and we know the roots, and therefore we can plot it accurately, just accurately enough to solve our problem. So it's going to start from the top, and it's going to have to pass through each of these, so we can do that, then let's start from the top, and we know we're going to have to swoop back up to get through here, and then we're going to swoop back down there. Boom. Absolutely beautiful cubic graph, may I say. Right. And now it's really easy. Now we've just got to visually look and see what values of x give us this function outputting negative numbers. We can see that values that are in between -4 and -1/3 are going to give us negative values. So that's our first set of x values that are going to solve the equation. If we have x greater than -4 but just less than -1/3, then those values of x will output negative numbers and it'll be all smash and dandy. Right. But are there any other places? Yes. Look, if x is greater than 3/2, we're also getting negative number outputs. So we need to include that as well. And I'm going to put a little or. And boom, there we go. We've solved our cubic inequality. How easy was that? Right, now let's just do just a little bit, a slightly harder one. Okay, my boys, let's do this next question. Now, it doesn't even look like it's going to be a cubic graph in question, because I've just got part A up here first, and it's going to be the first bit of this question. Anyways, let's take a look. We've got g of x, lovely little function name if I may say so, equals that garbage. A is given x plus 1 is a factor of g of x, fully factorised g of x. Okay, now, remember that fully factorised means that you write it as 3 whole linear factors, so we're going to need to do polynomial division, aren't we? Because we've got a factor, we've got the cubic in its own right, and if we perform polynomial division, then we'll be given the other factors for free. So that's what we're going to have to do. Big hint that you're going to have to do polynomial division here, pretty much all the time, never anything else. Anyway, so let's get on with our polynomial division. Remember that we have to write our cubic down first, that we're dividing. And then we write down the thing we're dividing by. Okay, now we need to remember the method. We need to subtract off some amount of this bracket. We need to subtract off something times this bracket such that it will cancel with this leftmost term here. So you'll see what I mean when I go through it. To cancel 2x cubed, we're going to need a minus 2x cubed. And we can do that if we put a minus 2x squared here, right? Because then we expand this, we'll get minus 2x squared and then plus another thing. So that will cancel with that. And the other thing is the important. We'll be left over with another minus 2x squared when you expand this out, which will combine with this x squared term here, and we're left with minus 5x squared minus 2x plus 3, and then we perform the same step again. Now we need to think, okay, what do we put in front of here to cancel out this leftmost term? Well, we're going to need a positive 5x squared, so if we put a plus 5x there, hope you can see that yet, then we're going to get 5x squared plus 5x, so this will cancel with that, and then we're going to get a positive 5x left over, and we're going to be left with 3x plus 3. We write down our factor once more, and now we have to think, what do we have to, then we think, what do we have to write down here so that we cancel this? We're going to need a minus 3x, so if we put minus 3 here, and we expand this out, we're going to get minus 3x minus 3, and what do you know? Everything cancels down to 0, which if you remember how the method works, then when it all cancels down to 0, you know you've done it right and you've found your factor. We've found the other quadratic factor. And what is the other quadratic factor? Remember, it's these numbers here, and then you take the negative of them. So what I mean by that is the other factor will be, we've got a minus 2x squared, so we change the sign and make it 2x squared. We've got a positive 5x, so we change the sign and make it minus 5x. And we've got a minus 3, so we change the sign and make it positive 3. Boom. Now that is the other factor of g of x along with x plus 1. Absolutely fantabulous, but we haven't actually answered the question yet because it wants us to fully factorise g of x. So we've got to factorise this whole thing right here. I'll meet you on the next board. Right, okay, my boys, to finish off this question, well, part A of this question, we're going to have to factorise this quadratic. Now, I don't really feel like doing a long factorisation, so you can do this. This is a personal exercise that I'm asking you to do. I've already done it. I'm just going to use the quadratic formula just on this factor here to get what the roots of this quadratic bit is, and then we can therefore derive the factors from there. So if you do that, if you go through all the calculation, you'll get that the roots just for this thing are x equals 3/2 and x equals 1. And then we know we know both the roots of a polynomial, so by the factor theorem, we can deduce that the factors must be x minus 3/2 and x minus 1 of this thing. So we've broken this thing into two factors, and then we've still got this right here. And boom, we've factorised g of x into 3 linear factors, answering part A. Done. Next bit. Okay boys, now the final part of the question, part B. Solve the equation g of x is greater than or equal to 0. So we need to find the values of x such that when you chuck them in g of x, you get numbers that are greater than 0 or are equal to 0. So as always, we're going to need to do the graph of this quadratic. So first of all, cubic. First of all, to graph the cubic, we need to know the general shape of the cubic, and we can derive that from the coefficient of x cubed, which is a positive number. Therefore, the cubic is going to start here, go swoop, 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 and then end up here. Okay, done. Second bit, we're going to have to figure out what the roots of the cubic are, so then we can plot them on the axes and accurately draw our cubic. But that's real easy because we can just get them easy from these factors right here. So let's do that. From this factor, we're going to get a root of 3/2. From this factor, we're going to get a root of 1. And this factor, we're going to get a root of a -1. Easy peasy, am I right? And now, let's just draw our cubic. It's going to start up here, swoop into -1, drop back to 1, and then swoop back up to 3/2. Rightio. Okay, now, time for the final shebang, the easy part. We're going to have to look at our cubic and think, okay, what values of x here are outputting positive numbers on this graph? First of all, we can see if x is greater than 3/2, that works. Okay, so cool. X greater than 3/2, absolutely fandabidozy. And now the second bit is if x is between -1 and 1, you're getting positive numbers, and so the final bit is x -1 and 1. Boom, there we go. Solved. Oh, right, solved our cubic inequality, real easy. So yeah, basically boys, that's how the method works. It's really not that hard when you get down and dirty with it, but some of the questions can just take a long time, but they'll be worth a lot of marks, so don't you worry about that. Anyway, thank you guys for putting up with me this episode. I'll see you in the next one. Please subscribe if you might. Help a little boy out. Anyway, thank you very much for watching, and I'll see you in the next one. Bye.